In our earlier video, we had proved that in any rectangle, the two diagonals of the rectangle would be equal in length. In this rectangle ABCD, we had arrived at the conclusion that the length of the first diagonal AC is equal to the length of diagonal BD. Now in this video, we are going to ponder upon the second question. Do the diagonals bisect each other? That is, whether AC bisects BD and whether BD bisects AC at the same time. By bisecting, we mean dividing each other into equal parts. So let me consider the point of intersection of the two diagonals as O. Now what do we have to find? We'll have to find whether OD is equal to OB and whether OA is equal to OC. Now in order to do that, we'll have to once again use the tools of congruency of triangles. But which are the two triangles which we are going to consider? We'll have to consider those two triangles where the two sides would be a part of the two diagonals, like this. So this white triangle would be one, and let me use green color for the other triangle. So this green triangle. So we'll have to compare these two triangles and find out if they are congruent. In case we prove that they are congruent, then we would have arrived at what we wanted to arrive at. So let's begin. We have the opposite sides of a rectangle are equal in length. That is AC, AD is equal to BC. This is the breadth of the rectangle. The opposite sides are equal. So these two sides are equal. So now we have one side of each triangle equal to the other. One corresponding side equal to the other. We do not know about the other two sides. So let's look at angles. Now, do we know anything about the angles of these two triangles? Now we'll have to think of the property of a parallelogram here. This line AD, let me extend the line a little so that you will be able to understand. This line AD would be parallel to line BC, right? A rectangle is basically a parallelogram. So AD is parallel to BC. So what is the property of parallel lines now? In case you have a doubt, you may refer to our math decoded parallel line properties. But let me explain to you clearly here. In case of a pair of parallel lines, if there is a transversal, here if I consider the diagonal BD as the transversal, then the alternate interior angles would be equal. The angles which I am marking in blue, these two angles are equal to one another because AD is parallel to BC and we have considered BD as the transversal. Now if you consider AC to be the transversal, you will be getting two other angles to be equal, these two interior angles, right? So now we have a clear view of this picture. We have two angles of each triangle and one included side equal to one another. So by the SAS congruency condition, we can arrive at this conclusion that triangle AOD is congruent to triangle COB, because angle at A is equal to angle at C and angle at D is equal to angle at B, and you have one side equal to each other. So because they are congruent, what are we inferring? By corresponding parts of congruent triangles, we have the two sides OD is equal to the corresponding side of the green triangle OB, right? And similarly OA would be equal to the corresponding side of the other triangle OC, and this is what we wanted to prove. The diagonals bisect each other. I hope you followed through this. So I have a yes here. Now whether the diagonals are perpendicular to one another, let's explore in our upcoming video.